Welcome to the Visual COBOL in a Nutshell series of presentations. This module will cover the SQL statements that are supported by OpenESQL technology. The ANSI SQL standard defines a set of statements that can be used to create, maintain, and manipulate data within a relational database. Most database vendors support extensions to the ANSI SQL standard, which, when used, would lock your application into that database, making it difficult to move to a different vendor. OpenESQL takes an agnostic approach by supporting a subset of the ANSI standard statements that will provide portability at the source code level when switching between database vendors like SQL Server, Oracle, and DB2. If you have existing embedded SQL programs that you used previously with Oracle's COBOL or IBM's DB2 preprocessor products, you might find that some of the extensions that you may have used will not be supported by OpenESQL, and some source code modification may be required. So what do we mean by SQL statement? Well, SQL statements are broken down into categories according to the functionality that they provide. Data definition language, or DDL statements, define the database structure. Data control language, or DCL statements, are used to create database roles and permissions. Data manipulation language, or DML statements, are used to manage data within a database, allowing you to retrieve, modify, and store data using tables. Transaction control language, or TCL statements, allow you to manage the changes made when using DML statements. Of these four categories, most embedded SQL statements fall into the last two. It is not the goal of this presentation to teach you entry-level structured query language, as this is a rather lengthy and involved subject. Instead, this presentation will focus on SQL statements in general and how they pertain directly to the OpenESQL technology. Let's take a closer look at each of these categories. Data definition language is used to define the actual database structure and schemas. These statements are usually executed in scripts within the database itself, but they can also be used within an OpenESQL program. The most common DDL statements that are used in OpenESQL are the statements to create or delete new tables or stored procedures. Most database vendors provide their own extensions to DDL statements, such as column types for binary data, etc., so the syntax may differ slightly between the different databases. Because of this, you will not find DDL statements documented in the Visual COBOL help. Please refer to your individual database vendor's documentation for exact specifications. The second category is data control language, and this is used to provide user access permissions to various database functionality. Like DDL statements, these are usually run within the database itself and are not used frequently within OpenESQL programs. DCL statements are also not covered in the Visual COBOL documentation. Please refer to your vendor's documentation for more information. Let's take a closer look at these first two categories. Okay, so this is in Visual COBOL for Visual Studio 2012. We have a real simple project here to demonstrate DDL and DCL statements. The properties in this project under the SQL tab have our SQL directive set. We're using ODBC in this case. Okay. The easiest thing is just to run it, so I will press F11 to start debugging our application. And all that this demo will do will be to create a table in the Northwind database and change some permissions, and also to add a stored procedure to the database. Okay, we're using SQL error handling with the whenever clause, so if an error occurs, it will perform this paragraph automatically. Okay, we connect to our database. That is successful. First thing we do is, if this table exists, the table called MF Customers, it will delete it. Here we can see that an error has occurred, and that is because we cannot drop the table. This is an expected error because the table doesn't exist yet. So we'll ignore that. And now we can create our table using the create table MF customers statement. These are all covered in the documentation for your vendor's database. We basically are just giving it a number of columns and their descriptions so that we can create this table. Okay, we've created the table. Now we can alter it using the alter statement to add a primary key using the add constraint. Okay, now our table's created. We want to create a stored procedure. Here we'll first drop the stored procedure if it exists. It doesn't, so we get our error that we can't drop it because it doesn't exist, so we ignore that. To create a stored procedure, you can do this directly in your COBOL program using create procedure. It will be called SP update, and you're basically giving this source code to what this will look like in SQL Server as a stored procedure. You're saying these are the parameters to pass here, and here's your code for the actual stored procedure, which will just update the table by setting it the values in the columns to the parameters that we pass. Okay, we've created that, and now we're into DCL statements, which we use to change the permissions. Here we're saying I want to grant insert privilege on this table that we just created to user Chris, and so on. Select, update on, and we're denying the delete access to a user called Chris. Okay, now none of that has actually been written to the database yet until we commit. So here we do our commit statement and disconnect. Okay, if we look over in our database, this is the SQL Server Management Studio. Northward, if we look at the tables, we can see here, here's MF customers. That's the table that we just created. Here's the columns that we defined. Okay, there's no data in there. We could check our user access here under permissions and see here's our user Chris with the access rights that we gave it using our statements: grant, insert, select, and update, and deny delete. Okay, and if we look down under programmability, under stored procedures, we refresh that, we can see here is our SP update along with the parameters that we defined. So our statements were successful, and we've now created our table and our stored procedure in the database. Okay, the third category is data manipulation language, and by far these are the most widely used statements in an OpenESQL program, as they deal directly with the access and modification of data within tables. In this presentation, we will demonstrate the use of the select into statement to return a single row of data into host variables or multiple rows using host array variables. We will also show how to use insert, update, and delete statements to modify the content of rows within tables. The cursor-related statements will be covered in a separate presentation. The OpenESQL implementation of the statements outlined here are compatible across different databases and will also provide portability when moving between native ODBC and managed ADO.NET providers. These statements are covered fully in the Visual COBOL help documentation. The last category is transaction control language. These statements are used in conjunction with data management language statements, allowing you to either make changes permanent to the database by committing a transaction, or to ignore all changes since the last commit by providing a rollback capability. You can also set the transaction isolation level to control the level of locking, which is done between transactions to ensure data integrity. Auto commit mode can be turned on using either a compiler directive or with the set auto commit statement, which forces a commit to be done automatically after each statement is executed. These statements are also fully covered in the Visual COBOL help documentation. One more topic to cover before we jump to our demonstration is host variables. Host variables are used to pass data between your application and the database. Normally, each individual column in a table would have a host variable defined for it, as tables are accessed at the column level and not at the record level like COBOL data files. OpenESQL allows you to define host variables using standard COBOL data types using a picture clause or by using the special SQL type is clause. In addition, for .NET Managed Code applications, you can also specify host variables using .NET data types like string, binary long, or system.datetime. Data types used must be compatible with the actual column definition in the table, as data is mapped between the two as statements are executed. There is a list of compatible data type definitions in the reference section of the Visual COBOL Database Access documentation. OpenESQL also supports host arrays so that multiple rows of data can be processed in one SQL statement. Null values can be inserted into and returned from a row using indicator variables, which can be paired with a standard column host variable. Let's take a closer look now at these DML and Pcl statements and how they work together with host variable definitions. Okay, so I will jump back into Visual Studio. We have a simple demo where we will insert some data into the table that we created previously using host variables, and then we'll manipulate that data in various ways. So the first thing we do is define our host variables. Here we define them in two different ways. The first way is using standard COBOL picture clauses. Okay. Host variables, you have one for each of the columns that we defined earlier, and each one needs to have a picture that corresponds to the column as it was defined in the database. Okay, so a numeric needs to be defined as numeric in COBOL, alphanumeric, picx, and so on. Okay, an alternative form that's supported by OpenESQL is using the SQL type syntax, and the preprocessor will look at that and generate under the covers standard COBOL. But this just provides an easier way of defining the data as it's defined in the database itself. Okay, either method can be used, and we will use both. Okay, we'll also demonstrate the use of null indicators. These provide a way of inserting null values into columns and for retrieving nulls out of columns. Okay, so we'll start up our program by pressing F11 to debug, and we'll connect to our Northwind database. First thing we'll do is insert a few rows into the database by populating the host variables, and then we execute an insert statement. Now all embedded SQL statements have an exec SQL and end exec surrounding them. Okay, the format in between can be anything. It doesn't have to look like this here. The number of spaces and indentations is completely up to you. Okay, for the insert statement, you specify the table name, and then you give it two sets of data. The first is a list of the columns that you want to insert data into that are actually in the database, and then the values that you want to go into those columns using host variables. And notice that the host variables always start with a colon. That's how the preprocessor knows they're host variables. And this data is inserted by position. So column number 1 gets the first host variable, column number 2 gets the second, and so on. Okay, so we insert our first row. Now we'll insert a second row using different data. And in this case, instead of populating the date field, we'll put a null in there. So the way to do that is to move a -1 to the null indicator for that field. And then in the insert statement, when you specify your host variable, you separate it with a colon and then have the null indicator after that. And when OpenESQL sees that there's a -1 in that indicator, it will insert a null into that column. Okay, so we insert that. Third row, this time we're using the SQL type host variables to show that you can mix and match these. It doesn't matter. Okay, and on our insert we also use those as well. Okay, so we've inserted 3 rows. Now we'll select a row out of the table. So we'll move 2 to custom, which is our key. And the select, we're saying select these columns into these host variables. Again, this is positional. Okay, and here we are using null indicators. So if one of the columns happens to be null, its indicator will be set to -1. And since this is custom 2, it does have a null date. Okay, we're saying to select where the custom equals the custom here. Okay, so we select it. Now we display the data that's returned. Okay, we can see we got our row back. When we get down to our indicator, it checks the indicator for -1. It is -1, so we know that the data is null. Okay, now to update data, we want to change the phone number of the number 2 customer to this new phone number. So we use an update statement, and we can say set the cust phone column to the cust phone host variable, okay, where the cust number equals 2. So that will modify just that column. The other columns in that row will be unchanged. Okay, for deleting, we move the value to the cust num of the row we want to delete, and we can give it the specification. Let's delete where this cust number equals the host variable. Okay, and now nothing has actually been written to the database until we do a commit. If we did a rollback here instead of a commit, everything would be thrown away and nothing would be written. Instead, we commit it and disconnect. Okay, we go over to SQL Server Management Studio, and we want to refresh our list of tables, and we take a look and we can see that these are 2 rows are in the database because we deleted one. Here's the updated phone number and the null in the column for the date. So our statements work correctly there. Okay. We jump back in. That was using simple host variables. This next demo shows the same demonstration, only using host arrays. You can see that the array variables are defined exactly the same way, except you have an occurs clause. And if you use host arrays in any of your statements, all the host variables have to be arrays, and they all have to have the same number of occurrences. What we're saying here is that we can specify that you can act upon more than one row at a time by using a table here, an occurs table. Okay, you can also use null indicators that are also in tables. So the way it works is if you specify 5 occurs levels, all the data at occurs level 1 will be for one row, occurs level 2 will be a second row, and so on. Okay, we'll start this up and demonstrate how to use host arrays. Okay, so here we're going to populate the tables, the occurs with the data. So instead of writing each one separately, we're actually populating 3 of the occurs levels of the table. This one here, we're also setting the date field to null for the null indicator at the 3 for index 3. Okay. The statements work exactly the same. In fact, you don't even reference this as a array. You can give it just the name of the host array, just like you would if it was a simple host variable. And you can use the for statement, the for clause, to specify the maximum number of items. Here we set max items to 3, so that's saying here we want to insert the first 3 occurrences in this table into MF customers. So each time it will insert one of the occurs, so it'll actually process 3 rows at one time. Okay. Here we'll do a singleton select. Now normally when you want to get multiple rows back at once, you'll use a cursor, but you can use a host array as well. So in our select statement, we're not specifying a for clause, so it'll say just bring me back up to 5 rows because that's the maximum occurs level. Okay, so now it would have filled all of those. And you can tell how many have actually been returned by the value of this SQL ERRD at level number 3, and it says that 5 rows were returned. Okay, so now we can process them. We'll go in a perform loop and display each one. Okay, here it's checking if the null indicator equals -1, and then it will display data as null. So it'll go through 5 times and jump out. If we take a look at what was just displayed, we can see that here's all 5 of our rows, and on the last one and the first one it says data is null. Okay, for updating rows, here we'll just move this new date to the date field for all the rows that were returned. So we'll update all rows to have the same date. Okay, we move this to max items, and now with the update clause you can also specify 4. So this will say for 5 of these it will do update MF customers. It will set that date field to the new date for each of the customers in there, for each one of those occurrences. Okay, deletes works the same way. You use the 4. Here we're setting it to 2, so only the first 2 occurrences in the table will be used to delete the rows. And then we can commit our transaction so it's written to the table. Okay, if we look back in SQL Server, so let me refresh this. Take a look. We can see the data in there is now rows 4, 5, and 6, and they all have that same date. The first 3 were deleted. Okay, so that's processing our statements. A couple of useful tools that you can use to gain more insight into how SQL statements can be coded are the OpenESQL Assistant and the Samples browser. The OpenESQL Assistant is a GUI tool integrated with Visual Studio that will allow you to interactively design SQL queries and then automatically generate the required source code for you. The OpenESQL Assistant is covered in a separate presentation. The Samples browser is located under the Visual COBOL group on the Windows Start menu. That brings us to the end of this Visual COBOL in a nutshell presentation of OpenESQL SQL statements. Thank you for watching and happy programming.